Thank you very much for that kind introduction. Yeah, I'm Daniel Sokolowski. This is joint work with Pascal Weisenburger and Guido Salvaneschi at the University of St. Gallen in Switzerland. And I will talk about automating serverless deployments for DevOps organizations. But don't worry if you saw the talk last year or online, it's updated. We have new data, we have new insights. So traditionally, software development and operations used to be separate disciplines, separate teams. And in between them, there was the so-called wall of confusion, which caused friction and slowed down the entire software production. And the aim of DevOps is now to tear down this wall and bring these different professions closer together in so-called cross-functional teams. And in DevOps organizations, you now have many of these cross-functional teams that each, as independently as possible, work on their own applications. But in many applications, like for example, SOA or microservice applications depend on each other. Like this is an example of the T-Store, which is a microservices application that has 6 microservices that depend according to this diagram on each other. And we were wondering, like, if these teams work independently on their applications, what does that mean for the operations? Is the operations also independent, or if they try to be independent, do they get this as a result? And if not, how do they actually achieve to get a working web page? So what we were wondering is operation decoupling in such setups really an issue? More precisely, we were wondering whether there are these application design time dependencies between applications. And if there are, do they carry on to the deployment time? So do these dependencies mean that the deployment and the undeployment of these applications has to be coordinated? And if so, how do currently experts and organizations do that actually? How do they coordinate? And to figure that out, we performed a survey with 134 IT professionals from industry. And we first asked them, your primary application, does it require on other applications to operate properly? And we figured out, yeah, 90% of them said at least one. That means most of the applications seem to indeed depend on other applications. And then we wanted to know whether these dependencies for them may constrain the deployment and the undeployment orders. And we figured out that this is often the case. Yeah, often these application dependencies constrain the order of deployment and undeployment operations. Then we wanted to know, like, what do you use for coordination? Do you use manual coordination? That means the people of the different teams have to phone, chat, or email each other to get this coordination properly done. Or do they have an automated solution for that? And 1/3 of the respondents said we solely rely on manual coordination. Only 1/4 used solely automated coordination. And overall, the majority somehow relied on manual coordination. And seeing that, we wondered further, like, but why is that? Do they perhaps not think that automated coordination could perform better? So we asked them for different metrics, which are typical goals of DevOps organizations, whether they think automated coordination would promise better performance. And similar, you see here, would mean they think that they may provide similar performance, and right of similar always indicates that they think that automated coordination promises better performance. And looking just at these, roughly at these diagrams, you see that the majority definitely thinks that automated coordination will promise better performance for DevOps organizations. So to sum up the survey results, we found out that applications in practice depend on each other across teams. These dependencies often constrain the deployment and undeployment orders. In practice, teams and organizations still rely heavily on manual coordination, even though they think automated solutions would provide better performance. So we were wondering what is lacking. So especially this conflict, why are not more of them using automated coordination? Is there something missing in the state of the art? Before we look deeper into that, let me introduce you to an example that we will use for the rest of the talk. And that example shall be just a simple static web page, yeah, as simple as it can be. We want to deploy one HTML document into an AWS S3 bucket. And this is a so-called resource graph, which is typical in declarative infrastructure as code applications, where nodes in the graph are the resources. So in this case, our bucket and the index page, the HTML document. And arcs in that resource graph are dependencies between the resources. So in this case, the index page depends on the bucket, which means the bucket has to be deployed before, and the index page must be destroyed before the bucket can be undeployed. And I want to talk with you about coordination. So we need two teams. We have two teams here. It's the provider team that is in charge of the deployment of the bucket, and we have the editor team, which is in charge of the index page. Okay, so having that example introduced, what are now the use cases for coordination? And the first one is asynchronous deployment. So these two teams have to always ensure that when they deploy, the bucket is deployed before the index document. The second one is safe undeployment. That means when they want to undeploy the bucket especially, they need to make sure that first the index page is undeployed. And the last, third use case is reactive updates or reactive update propagation. That means if something in the bucket configuration is changed, that change needs to be forwarded to the index document. So what are the current means to coordinate on these three use cases for the two teams? Well, there are more or less two different ways. The first one is manual coordination that I already mentioned, where they phone, chat, or email with each other, or talk across the desk if that is possible. But the problem with that, it tends to be slow. It's rather unreliable because there are humans involved, and it always requires synchronous communication when you want to do something. The alternative is centralization. That means both teams agree on delegating it to one central authority, which may be another team, one of the two teams, or even a central system. But I think there's clearly a gap, and that gap could be filled with decentralized automation. Yeah, so something that automates to improve on these points, and something that still is decentralized to not limit the independence of the teams. And we propose in our paper a solution to that, and we call it Muse. Muse is an infrastructure as code tool, because infrastructure as code is the DevOps technology to automate software operations, and this is an operations problem. However, today's infrastructure as code tools, modern tools like Pulumi, for example, they cannot do this automated coordination. And that is mainly because of two shortcomings that we solved with Muse. And the first one is, the first thing we had to introduce was strong interfaces, which means today these deployment descriptions don't have a way to make explicit that they interact with another deployment. And to automate the coordination, we need to have somewhere defined this explicit connection. And we do that in Muse by defining offers. If we offer our service or resources to another team's deployment, we define an offer. And that we want to consume such an offered resource or application, we do by defining a wish in a deployment. The second aspect we had to improve on was today deployments are like one-off tasks. These programs execute once, perform the deployment, and terminate. The thing now is with coordination, we need something that the deployments continuously can communicate with each other and can react to things happening in the other deployment. And for that, we need to decouple the operations by making them long-running processes instead of one-off tasks. So that was very abstract. Let's get concrete and back to our example. This is again our example, the two teams, and this would be a Pulumi TypeScript description of this very simple deployment so far. So we define here these two resources, and this reference to the bucket object defines the arc. The first thing that we do is we want to separate the deployment for the teams so that each team has an independent deployment. Then we introduce in each of the deployments a remote connection resource, which makes the connection to the other team's deployment explicit. And we define an offer resource in the provider's deployment. And this offer resource defines that the provider's deployment provides to the editor or offers to the editor the bucket. And on the other side, then, we define a wish resource. And this wish resource in the editor's deployment defines that the editor's deployment wishes from the provider a bucket that it then uses to configure the index document. Yeah, so like this, we have this connection from in both deployments explicit, and that we can now use in the Muse runtime to fulfill our use cases. So the first one was asynchronous deployment. So independent of when each of the teams starts and stops their deployments, it is always ensured that the bucket is deployed before the index page. Same for safe undeployment. Independent of when they start and stop their deployments, it's always ensured that the index page becomes undeployed before the bucket is undeployed. And lastly, the runtime ensures reactive updates. That means if something changes here in the configuration, that change is automatically transported to the index. We evaluated Muse on the T-Store case study that I showed you briefly in the beginning by implementing that deployment for DevOps organizations in Muse and its two competitors, Pulumi and CDK. And we see Muse needs a little bit more lines of code in total, not that much, but a little bit more. However, it's the only one that automates the deployment coordination. Yeah, so it's the only one that can effectively automate the deployment coordination, and therefore the coding overhead is really negligible, at least in my opinion. At least it's not significantly big. Then we evaluated the performance by just deploying a simple web server. And we did that with all three solutions, and our results show that Muse and Pulumi's performance is similar. AWS CDK's performance is a bit worse. We then took multiple of these deployments and introduced dependencies between them. Once a sequential chain of dependencies, and the other time parallel dependencies. And as we expected for the sequential dependencies, the deployment time is linearly growing. And for the parallel dependencies, the deployment time is roughly constant. And this experiment shows that the coordination of Muse does not introduce significant performance overhead. Lastly, we wanted to see whether we can apply the idea of Muse also to already existing realistic infrastructure as code programs. So we chose all 64 publicly available Pulumi TypeScript deployments that use stack references, which is currently the only way in previous solutions to somehow say I provide something to or make something available for others to consume. And we introduced in these infrastructure as code programs our wishes and offers to make that connection explicit. And that was straightforward. It was so straightforward that we could easily automate it with an AST transformation and perform it automatically for these 64 projects. So Muse is also applicable to already existing deployments. Yeah, more details, of course, you find in our paper. All our code, Muse, and artifacts for the evaluation are online on GitHub and Zenodo. They have been evaluated to be functional and reusable. We also have a web page. It's muse.rocks, where you find all content of this talk and the work that builds upon it that we did in the past year and in the current year, and most probably also in the future. This is the end of my talk, automating serverless deployments for DevOps organizations. I presented to you the results of our dependencies in DevOps survey, which clearly showed that there is something missing in today's solution to coordinate deployments in DevOps organizations. We think that gap can be filled with decentralized automation and propose Muse as the first infrastructure as code tool that actually can automate these deployment coordination for DevOps organizations in a decentralized fashion. Thank you very much for your attention, and I'm hoping now for your good questions.